Okay, Algebra 2, Chapter 3, Section 4. Here is a real-life problem now that would be using linear programming. So this will help make this make a lot more sense. Landscaping company has crews who mow lawn and prune shrubbery. The company schedules 1 hour for a mowing job and 3 hours for a pruning job. Each crew is scheduled for no more than 2 pruning jobs per day. Each crew schedule is set up for a maximum of 9 hours per day. On the average, the charge for mowing a lawn is $40 and the charge for planting or pruning shrubbery is $120. Find a combination of mowing lawns and pruning shrubbery that will maximize the income the company receives per day for one of its crews. Okay, so that's a lot of information. Let's go back and go through this and figure out what we've got. So what's the question being asked basically? And we're being asked to maximize our income. So what can we do to make sure that we make the most profit we can in a day? So we got to go back and figure out what information we have. So a landscaping company has crews who mow lawns and prune shrubbery. The company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. So we need to know how many mowing jobs and how many pruning jobs. So that's a great place to start. Is let's define our variables. So x could be the number of mowing, and y could be the number of pruning. Okay, and we know it takes 1 hour for a mowing job and 3 hours for a pruning job. So if I can put 1 hour here for mowing and 3 hours, just to make some notation so I can find this all later. Each crew is scheduled for no more than 2 pruning jobs. Pruning is y, and pruning can't be greater than 2. So here is our first constraint that we have. So we want our y to be no more than 2. No more than, y is no more than 2. No more than means less than or equal to. Each crew is scheduled for a maximum of 9 hours. Okay, so it takes 1 hour for a mowing job. So 1 hour for a mowing job and 2 hours for a pruning job. And we can't spend any more than 9 hours. Okay, here's another constraint. And this last part is maximizing a profit. That is going to be our function we're going to try to find the maximum for. We're going to hold on to that information for later. We actually have 2 other constraints that we might not think about. Can we prune or mow negative? Okay, the answer to that would be no. So that means that y has to be greater than or equal to 0, and x has to be greater than or equal to 0. Once we have all of our 4 constraints, we're ready to start graphing them. And then again, we'll deal with the second part, our function that we're trying to maximize, in just a bit. So let me grab a color. So I want y to be less than or equal to 2. So y is less than or equal to 2. Here's y equals to 2 right here. Let me grab a line. So y equals 2 is there. And again, we want to shade, oops, I didn't want to do that. Let's see. Go back and grab my pen. We want to shade that way. Y has to be greater than or equal to 0. Okay, so I need another line here. And maybe I can grab blue for that one. So y has to be greater than or equal to 0. So there's y equal to 0. And in this case, I need to shade that direction. So I know I'm between the 2 lines there. I know x has to be greater than 0. So I need another line. And that's the line where x is 0. And I need to be greater than it. Greater than, it's going that way. And I've got one more constraint. This 1x plus 2y is less than or equal to 9. So let me rearrange that one. So if I subtract the x from both sides, I would be getting the 2y is less than or equal to negative x plus 9. And then I would need to divide both sides by 2. Right? Divide by 2, divide by 2, divide by 2. And so y is going to be less than or equal to negative 1/2 plus, and 9 divided by 2 is 4 1/2. Okay, so then I'm ready to grab my last equation there, and need a color. So why don't I grab purple? So we'll do that one in purple. And so to graph that one, I need to go up to 4.5. So 1, 2, 3, 4.5 is right about there. And I'm coming down 1, forward 2. So down 1, forward 2, down 1, forward 2, down 1, forward 2, down 1, forward 2, down 1, forward 2. And grab a line and put my line in there. Grabbing a purple color. Right like that, just a little bit low, and move that up there. Okay, and that's my last constraint, so I know I'm going to be below that one, above this one, to the right of this one. I just don't know if I'm inside or outside to know which direction to go for the purple one. So if I plug in the point 0, 0, that would put 0 is less than or equal to, oops, that's 1/2 x, forgot my x. 0 plus 4.5. Is 0 less than 4.5? The answer is true, so I'm actually shading this way. So I want this feasible region right here. So let me grab a highlighter. And I want this region right in here. That satisfies all of my constraints. My lines are now borders, and so they would be bounding my feasible region. So I'm not quite done yet. I need to find all my corner points, because then I'm going to have to maximize my function. So I can either find my corner points first, or I can write my function. Since I'm already here on my graph, I might as well find my corner points. So let me grab my pen back here. This corner point we don't care about. It's not in our feasible region. So we come down to this one, and that is the point 0, 2. This is the point 0, 0. This one out here is the point, well, we're not sure. It's 1, 2, 3, 4, 5, 6, 7, 8. We're thinking it's 9. Thinking the x is 9. If we put 9 in for, well, we know on the purple one it's 0, that y is 0. So half of what is 4.5, and it's 9, so 90 does work. So that's 0.90. And then we've got no idea which this one is. We've got a good guess. So the red line is definitely on 2. Right? So that's the y value of 2. So if I plug into this equation down here, where y is 2, so 2 is less than or equal to negative 1/2 x plus 4.5. That would be how I'd solve for that by substitution. So then I'm going to subtract 4.5 from both sides. Minus 4.5. Oops. 4 1/2. So 2 minus 4 1/2 is negative 2.5. And then you'd multiply both sides by negative 2. So x would be, multiply that side by 2, negative 2. So that's going to be a positive number. And 2 times 2.5 would be 5. If I count over 1, 2, 3, 4, 5, that pretty much fits it pretty well. So that would be the 0.52. Okay, so I've got my corner points. I've got 4 of them. This is quadrilateral, so I would have 4 points. And then the last part then is to figure out, okay, if I want to maximize my profit, I need to start looking at my profit. So on the average, we're going to charge, for mowing a lawn is $40, and mowing is X, right? So it's 40 times the number of mowing jobs, or 40X. Okay, and then we're charging $120 for pruning shrubbery, and pruning was Y, so it's $120 for every Y, for every pruning job, so plus 120 for every Y. And that's going to be this, what our X oops, comma y. Let me fix that up a little bit. Okay, so that's our feasible, our function we're trying to maximize. So then we're going to try each one of these points in our function. And how many points do I have? I've got 4, so I'm going to grab a table. And I've got 3 things I need to keep track of. Oops, and I did it again. I forgot to bring that all the way down, so I need some more. Insert row, insert row. It's 1, 2, 3, 4, we're good. Okay, so I've got my x, I've got my, oops, got my x, got my y, and then I've got my 40x plus 120y. And we want to know which one is going to make it the most sense, or make the most profit. So if you plug in 0 and 0, you're going to get 0. So that one's definitely out. We knew that one. We're not sure about the rest of them. What if we went straight up and we did just 2 y's? So that's just 2 pruning jobs. Okay, so we're going to have 0 mowing jobs and 2 pruning jobs. 0 mowing jobs, that means none of the 40s. And 2 prunings, so that's 2 times 120, that's going to be 240. It's a decent amount of money, so that could possibly be right. I'm going to try this one over here. So what if we mowed 9 lawns and did 0 prunings? Okay, 9 lawns and 0 prunings. So 9 times 40 is going to be 360 and no pruning. So that's actually worth more money to the company if we just mowed lawns and didn't prune at all. What if we did this combination where we did 5 lawns and 2 prunings? Let's plug that in. So 5 lawns and 2 prunings. So 5 lawns, that's going to be 200. And 2 prunings, that's going to be 240. So 5 lawns plus 2 prunings, that's going to be 440. Looks like that's definitely our maximum for a profit. So our maximum is right here. 5 lawn mowings and 2 prunings is going to be $440 and maximize our profit. Pruning. 2 pruning is $440. So that would be our answer to our question. Question being asked, how do we maximize our profit?